So, like I said, there was this mathematician a long time ago. He came up with this pattern, and it's called Pascal's triangle. See, it makes a triangle, and it goes like this: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on. What I want you to do, and don't give it away if you've seen this before, but try to figure out what the next row would be based on the pattern that you see. You always can add two numbers, like 2 and 1 gives you 3, 3 and 3 gives you 6. 1 and 5 is 6, 5 and 10 is 15. So what will the next row be? It'll always start with a 1. 7, 21, 35, another 35, 21, 7, and 1. So it's always adding the two numbers above to get the number below. And we're going to use that pattern to answer the questions on the sheet that I just gave you, on the first page. But the other thing that I want to show you is where those numbers actually come from. Because it's kind of a random pattern for him to have come up with, right? But here's where they come from. The first number is 0, choose 0, which is 1. How many ways can you choose 0 objects from 0? 1. You just don't. And then the next row is 1, choose 0, and 1, choose 1. And then 3, choose 0, or sorry, 2, choose 0, 2, choose 1, and 2, choose 2. If you calculate all of these combinations, that's how you get this triangle. Adding up the numbers, that's the pattern that he noticed when he looked at combinations. So the pattern kind of came out later after looking at what happens when you do all the combinations of choosing a certain number, choosing from a certain size group. So if you do 3, choose 0, 3, choose 1, 3, choose 2, and 3, choose 3, that's all the 3 choose somethings that there are, right? So that's the whole group of combinations of 3 objects. And then combinations of 4 and combinations of 5. There are lots of interesting patterns when you start looking at combinations. But this is kind of what Pascal came up with, is this triangle. But it's kind of interesting, if you look at this row that Tyler came up with, 1, 6, 15, 20, 15, 6, and 1. That's going to be 6, choose 0, 6, choose 1, 6, choose 2, 6, choose 3, 6, choose 4, 6, choose 5, and 6, choose 6. But not just the triangle, but you notice that 6, choose 1 is the same as 6, choose 5. They're both 6. 6, choose 2 is the same as 6, choose 4. And that's an interesting pattern that we could get into and kind of talk about why that happens. If we just kind of quickly do that. 6, choose 2. Oops. That's not how you write 6, choose 2. 6, choose 2 is equal to 15, right? And that's equal to 6, choose 4. Well, why is that? Why would those two things be the same? Moving on to this, which is an application of Pascal's triangle. Determine the number of paths from point A to point B if east and south are the only possible directions. We did a question like this before, right? And we said, well, if you have to travel east and south, you're going to have to travel east how many times? 3. And how many times will you have to travel south?
3.
Also 3. So do you see that? East, 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 south, south, south. And you don't have to go in that order, right? You could go east, south, east, south, east, south, or south, 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 east, 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 or a whole bunch of different possibilities, which is what we're trying to figure out, is how many possibilities are there. But no matter what, you're going to have to go east 3 times and south 3 times. And so we said it's the same as arranging the letters E, 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 S, S, S. So if we do it as a permutation with factorial notation, we can say that's 6 factorial divided by 3 factorial, 3 factorial. That's how we did it before. Because it's permutation with identical objects. So you divide by the number of identical objects factorial. That's equal to 20. So there are 20 different pathways. But I want to show you how you can use Pascal's triangle to come up with the same number. Now actually, if I was given this question to do, I would probably do it the way we just did, not using Pascal's triangle, but there are some of them that you can't do this way. So I want to show you how to do it with Pascal's triangle so that when you come up against one that you can't do just like this, that we can figure it out. So the way it's going to work with Pascal's triangle is wherever you're starting, you're going to put a 1. And then really what you're looking at is how many ways are there to get to each particular intersection of the lines. If you think of this as streets, like a grid of streets in a city or something. How many ways could we get from A just to here? 1. So I'm going to put a 1 there. And how many ways could we get from A to here? Also 1. What about to here? There's just 1, right? You have to walk straight down. So that's also a 1. What about right down at that bottom corner? Also a 1, because the only way to get there is to walk straight down. So there is only 1 way to get there. And we can do the same thing across the top. Going straight across or straight down, there's only 1 way. But then when we start to look inside, like at this spot, you could get there by walking east and south, or by walking south and east. So there are actually 2 ways to get there. And then if we look at this block, well, we could get to that block by going east, south, south, or south, southeast, or southeast, south. 3 different ways. So I'm going to put a 3 there. But we don't want to have to actually try to figure out everyone like that by actually mapping out the spots, right? If you look at this on a diagonal, you'll see Pascal's triangle. If we go this way. 1, 1, 1, 1, 2, 1, 1, 3, what'll that be? 3, 1. So do you see that that's Pascal's triangle? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And then we're just going to continue. And if you remember how we come up with Pascal's triangle, not the combination way, but just the adding way, the way we get it is by adding the previous numbers. So if you are looking for this block, it's just 1 plus 1. This one's going to be 1 plus 2 is 3. What's this one going to be? 4. 3 plus 1. So that's a 4. This one is 3 plus 3. So that's 6. If we continue here, 3 plus 1, that's 4. And then we'll put a 10 here because it's 6 plus 4. 6 plus 4 again to get a 10 here, right? These 2 paths lead here. So that comes to a 10. These 2 paths lead here. And then to the B, the paths leading to the B, 10 plus 10 is 20. Which is what we also got using the other method. So if we have a look at this one, similar question, determine the number of pathways from point A to point B if east and south are the only possible directions. I think that's the exact same instruction as the first one, but the diagram looks a little different. So I want to show you again both ways to do it. If we're going to do the factorial way, the permutations, We need to break this down into two problems because there are two rectangles there. So in the first rectangle, you need to go east, east, south, south. So that's 4 factorial divided by 2 factorial, 2 factorial. And then you need to walk from, so that's getting you from A to here. And then we need to go from that middle point to B. And so to do that, we're going to go 6 factorial over 3 factorial, 3 factorial. And what mathematical operation has to go in between those two pieces? Multiplication, right. Because we're walking from A to this center piece and from that center to B. So, and we think of multiplying. This comes out to 120. So now what I want you to do is try doing it the Pascal's triangle way and see if you also get 120. If you take a look at this question, which I know some of you have already tried, but this one we can't do the factorial way, the one that's projected here, that's on your worksheet, and it's because of that swamp or park or whatever that is in the middle that you can't walk through or drive through if these are streets that you're driving on or whatever. So we have to use Pascal's triangle on any one that's not just a uniform rectangle or a series of uniform rectangles.